Hello, my name is Craig Lee, and I'm here to talk about federation management using Keystone. And this is also work with Dave Bernstein. I've been doing some work with him with regards to federation, and he is the managing director of Cloud Strategy Partners. He's also the chair of the IEEE P2302 working group on standards for intercloud operability, and have just a few slides about that specific work later on and how it relates to cloud federation using Keystone. So to start off with, Keystone, is starting to address federation, but the main use case that they want to address is basically pairwise federation, doing cloud bursting from a private cloud to a public cloud. Now, of course, that's a very important use case, but that is actually just one instance of what I would call, general federation. And general federation is something I've been looking at in terms of other application domains like disaster response. But of course, we could also talk about being able to do, business-to-business types of federations or government-to-government, agency-to-agency, those kinds of things. What I term a federation is really a security and collaboration context that allows you to manage how these different organizations would share their resources, be they cloud infrastructure resources or arbitrary resources, such as things like access to databases, RSS feeds, MapReduce, or other services that are standards like geospatial services, map services, and so forth. Now, how can Keystone be used to manage general federation as well as infrastructure federation? So I'm going to go talk a little bit about what the fundamental requirements are for federation and also possible design and implementation options. For historical reasons, I did a lot of work in the grid community, so I've been using this notion of this virtual organization as the construct for managing federations. We could even call that a virtual domain or a virtual project. Those concepts are all sort of related, and it all depends on how the Keystone object model is actually used to manage these federations. Okay, so I'm going to do a brief review of the general federation management design space, and I'm going to talk a little bit about this KeyVOMS implementation that we've done as a centralized third party, and then I'll review some of the work that's being done for the IEEE Intercloud test bed. Okay, so this is the fundamental authorization and authentication and authorization challenge for a distributed environment. You have this notion of an IDP that a user will authenticate to, and then they'll get a token that a service provider actually authenticates. If you have two of these different environments, the fundamental challenge is how does a user from one domain actually discover and use a service that's being offered in a second domain? Okay, so we can sort of divide this into two fundamental sides. On the client side, you have to worry about federated authentication and service discovery. And then on the server side, they have to be able to do the federated credential validation and authorization. And we can look at those two things separately. Just as a theoretical or a logical approach to this, we can do the same kind of authorization and authentication using a conceptual VOMS or VO management system that looks like this diagram here. So, and as I noted, this could also be called a virtual project as opposed to a virtual organization or a virtual domain. That's really not terribly important. Obviously, there has to be an agreement about what these things are called, but I'm not really married to the name virtual organization. So, but to persist with using this terminology, there's some abstract concepts that go along with it. It's a security and collaboration domain that's not exclusively owned by any one administrative domain. It has members that can be assigned roles or attributes, and partners that are participating in a VO can contribute resources, meaning that they can actually make their services available to others in that context. So in terms of a VO management system, that is the thing that somehow has to maintain all the member identity attributes and the authorization attributes. It has to enable the service discovery, and also it has to enable the validation of those member authorization credentials on service invocation. Okay, so in terms of actual implementation, to go from this sort of logical concept to actual implementations, we can talk about centralized or distributed implementations. Obviously, the centralized ones are easier to implement because you have a trusted third-party VOMS. It's a one central place to put all that kind of stuff. It makes things like revocation easier and faster, but it is also a single point of failure. We can talk about distributed implementations, and this is where you would have to have trusted peer-to-peer VOMS or keystones that would talk to one another. These would be typically harder to implement. Revocation takes longer because it has to propagate, but you could say there's no single point of failure. Okay, so now this is something I think is very important, is how does the Keystone object model support these options? So I just lost the screen there. Yeah, okay. Okay, so rather than explain what the Keystone object model looks like right now, this is what I feel is a reasonable object model that would be used to support these kinds of federations. In the terminology that I've been using, Keystone domain would essentially be a virtual organization. And so roles and projects would be specific to this VO domain. Users would not necessarily have to be owned by a domain. The important thing here is that a VO domain is the construct that manages what both users and services can do. They manage how users can access those services that are being made part of a virtual organization. So this is essentially what would happen in a centralized implementation. So we've actually demonstrated this using what we call KeyVOMS. This is a third-party VOMS, and it's essentially just a repurposed instance of Keystone. It uses a domain as a VO. It has a service catalog that can be used for application-level services. So the way that this works is that there's essentially just three predefined roles that control how the whole thing is used. There's a VOMS admin that manages the entire thing. There's a VO admin that can manage an individual VO in terms of who's a member, who's not a member, what roles that they have, and so forth. And then at each participating site, there's a VO site admin that has the authorization to register services. And they can control what roles that a user has to have in terms of invoking any one of their services. Okay, and we implemented a simple example of using KeyVOMS to manage RSS feeds. So in this situation, we have a simple command line client that we built that allows these different roles to participate. And so we defined a simple VO that had several RSS feeds registered in the service catalog. These users were created that had different roles that allowed them to access these different RSS feeds based on their project membership, such that when, say, like a user A would authenticate with project scope, they would only discover the RSS feed that they were authorized to discover and use. And so we demonstrated this with using this very simple policy enforcement point that would actually do the VO authorization and get the right tokens back. And if all that succeeded, then our feed parser would actually go off and retrieve content from, in this case, the New York Times RSS feed. And so this actually demonstrated this whole tool chain working from start to finish. But this is just a simple a centralized third party. Now, if you want to consider what would happen with a peer-to-peer keystone, if we didn't want to have this trusted third party, how would two keystones have to interact? Now, this is more complicated than I have time to go through right now, but this is, the issue is that, a user authenticates to their local keystone. How do they find all of the other services that the other keystones might be offering in the particular context of that VO? Once they do that and they try to invoke some remote service, how does that remote service validate their credentials and enforce the right policy? So this next slide is not meant to be an eye chart, but I have slides for all these things, all these options in a different slide deck, but it all goes back to this notion of how the different keystones are exposed to the other party. The scalability issues with regards to whether it's just the Keystone auth URLs are returned or whether the entire service catalogs are returned. But I will go through those things later. Okay, now in terms of next steps, okay, there's lots of options here. How are we going to test some of these things out? Okay, besides this notion of Keystone everywhere, what's the minimal configuration and common interface and functionality that needs to be decided on, and how can we essentially determine what works best? Okay, so this is where the IEEE P2302 working group comes in, because they do have this Intercloud testbed project with the participants that are all listed here on this chart. So this is sort of an issue of scalability at this point, because we can easily talk about pairwise federation between two different instances. But what happens when we start talking about global scale interclouds, where you may have some unbounded number of sites that want to collaborate in some sort of federation? So there's some very thorny scalability issues that would have to be addressed to make this work. Okay, and this really is my final slide. And I just want to close with some of these final observations. Keystone is actually very close to what's needed for this general federation management use case that I've been sort of interested in. That with minor changes to the object model, I think that Keystone can really be generalized to address this much wider issue of a general federation. There's still these outstanding issues of centralized versus distributed, and the scale from going from simple pairwise federations to global interclouds. There really is no best federation approach. That whatever is most appropriate depends on what your application domain is, and there's certainly enormous issues that are non-technical that are going to have to be addressed. There's all sorts of cultural, political, and governance issues that would have to go along, and so this is again where something like this Intercloud testbed project would be appropriate. So we just need more experience with applications and demos. And with that, I thank you for your attention.